A very good morning, all of you. I, Professor Rajkot from Christ Institute of Management, Rajkot, welcome you in the e-tutorial on the subject of production and operations management. In production and operations management, one of the very important aspect that is project scheduling. If you have the schedule is of the time with respect to the jobs to be performed, rather we can say jobs to be performed with respect to the time. So if we have the proper schedule of the work to be done in what time duration, then the efficiency and effectiveness will be very much high. For that reason, in the year of 1957, for the project of the US Navy submarine, they developed this particular technique known as a PERT technique, and today we are going to learn the PERT technique in detail. PERT, if I give you the description of PERT, that is Program, Evaluation and Review Technique. My friend, in 1957, you can imagine, before so many years they have developed this particular technique and we are learning now. Now, if we compare with the other techniques are available into the field related to project scheduling, the most important networking techniques are CPM and PERT. CPM is critical path method and PERT is program evaluation and review technique. Now in critical path method, it is a difference if we see between these two methods. Then in critical path method, the time duration required for each activity, each job to be performed is known to you. It is known to you. While in the case of the different types of projects, you don't know that exact time duration and exact resources that you require, so that you are running on the basis of the probability. That's why this technique is known as a probabilistic technique, while in case of CPM, it is deterministic technique. Now without wasting much time, let us go for this program evaluation and review technique. Now to understand in detail how the different jobs and how the different timings and the probability will help to determine the project time duration, I tell you that time duration will be the estimated time duration, not the exact time duration. That's why it is based on the probability estimation. Now let us see this particular example to understand the program evaluation and review technique. The example, if you see the table, then there are different activities to be performed, and those activities are in the first column, A, B, C up to I. And then the second column is the precedence activity. Precedence means before that particular activity, if there are any other activities to be performed, so that logic is given in that precedence activity. So as per a few of the activities, you cannot perform directly. So that logic is helpful in developing the network. And you can see the difference in CPM, we have only one time duration, while in case of PERT, we are having three different columns for the time duration. If you read the first heading over here, that is the optimistic time, second is most likely time, and third is pessimistic time. I'll tell you, my friends, the difference between three time duration. Optimistic time is the minimum time duration that you require to complete the task given to you. At the same time, most likely time is the time duration that you require mostly while you are performing the same task. And lastly, the pessimistic one, that is the most time taken by you for the same job. So I'll tell you the example if I compare with this particular three things. If you need to do a painting on the body of a car in a manufacturing company, then it might be possible that efficiently you are working and you can complete that particular painting of the car with the optimal time, that is a 2 week. But at the same time, it may be possible that due to some hurdles, due to some changes in the painting work, it may require mostly the 4 week time duration. But the most of the time you require, sometimes it happens like, you need to change the color, the machine is not working and the person is not having a good health. So due to some unexpected reasons, the time taken for the same job, it is the most. So if you see these particular three, 2 is minimum, 4 is in between, and 6 is the most time. Right? So, as I said in the beginning only, this is a probabilistic approach. In the probabilistic approach, these 3 time durations are required to estimate the time. This is not the exact time, it is based on the probability. Now, let us go ahead without wasting much time. Now, if you see the question, they will ask the first thing, that is to draw the PERT network diagram. To draw the network diagram, we have 2 techniques, activity on arrow, activity on node. Now, in case of CPM and PERT, my friends, remember we are going to use the technical activity on arrow. Now, let us start drawing the network first, because that is a crucial one. In a sequence, if you see, there are number of jobs to be performed in a sequence. The first one is A. Now, there is no precedence for A as well as B and as well as C. So, for these 3 activities, there is no precedence. So, in a queue, if we are standing and there is no one is ahead of us, that means we are first in the queue. So, similarly, this project starts with 3 parallel activities, that is A, B and C together. As I said, activity on node. So, we are going to draw a 3 arrow starting from a single node. Remember, in case of activity on arrow technique, the network must have to start with a single node only and must be ended with a single node. Now, after that, in a sequence, that is D, and then after it is E. For both the activity D and E, the precedence one is A. That means from A we are having 2 activity, that is D and E. So if we see this particular A activity is over here, so after A we are having 2 arrows. One is for activity D and other is for activity E. Now, next in the sequence, the most important part, activity F and G. But if you see activity F and G, that is from the activity where activity B and D are merged together. This is known as a merge event. As 2 activities are together, B and D, it is known as a merge event. Now, if we see in the diagram, B is over here and D is over there. Then how to club these 2 activities? That's a difficult one. So for that thing, my friend, remember we need to have the correction over here. We can directly draw this activity D rather than drawing this arrow over here. We can directly go for clubbing the activities, because we know that we need to club activity D with the activity B in the coming time. So rather than drawing over there, I should draw from A. There are 2 activities, one is D, other one is E. Right? Now, from the place where B and D are together, we are having 2 activities, that is F and G. But if you see the precedence column, you require F to be merged with activity C. So, we'll not do mistake again. So, from B we are having another activity, and that activity is known as a F activity. And another activity which is from the place where B and D are together, and that activity is activity G. Now, so this will be activity G, and lastly, from the place where C and F are together, we are having activity called H. So we'll draw an arrow for activity H, and the last activity, that is from E. From E we are having activity I. But if I draw an arrow like this, then what happens? My network started with a single node, but it is ended with a 1, 2 and 3 open-ended nodes. But as I said earlier, your network must be started with a single and must be ended with a single node. So what we will do is, we will correct it. We are going to draw a single node over here, which is in the center part, and we will connect all these last activities to that particular node. You see, this is the correct network. It is starting with a single node and ended with a single node, and it follows all the consequences given in the question. Now, after this drawing the network, we need to give the numbers to the node. Remember, while giving the numbers, the tail of an arrow node must have the large value compared to the, I made a mistake, like tail must be the smaller compared to the head of the arrow. So if you see 1 to 2, so this is the arrow, so head over here, so 2 is greater than the 1. So in that way you can give the numbers to the node. Now after this we need to mention the time duration for each activity, but this question is having 3 time duration: optimistic, pessimistic and most likely. Now we can do exercise on any one particular time, and for that reason they will come up with the new time duration that is known as the estimated time for each activity. Now let us find out estimated time, and for that we'll prepare a table of the activities and their expected time. So that A, B, C, D, E, F, G, H, I, and the time duration which is known as expected time. I am repeatedly saying expected just because it is based on the probabilistic approach. So this is activities, this is the expected time TE, and lastly we are going to have one more, that is a standard variance, standard deviation, and on the basis we are going to find out the variance of each activity. Now how to find out the 2 columns mentioned over there? One column, the first one, that is saying about estimated time. The formula for estimated time is A plus 4 times N plus B upon 6. In this particular equation, A is nothing but it is the optimistic time, M is most likely, while B is pessimistic time. If you put the values of each activity in the formula, like let us start for the first A. So for A, the optimistic time is 2, so that is 2 plus most likely time is 4, so 2 plus 4 into 4, 16, so 2 plus 16 is 18 plus 6, so 18 plus 6 is 24. 24 divided by 6 is 4. So estimated time for A activity, it will be 4. Similarly, you need to find out the estimated time based on this particular equation for each activity. I'll write down on the board. So that estimated time over here is 4, 6, 13, 5, 15, 10, 6, 16, and lastly it is 10. Now, one more thing which is the very important. Why it is important? Because PERT technique will follow the normal distribution beta curve. Now, if you see the normal distribution beta curve, that required a z-score, and z-score will require 3 important things, that is x, mu and sigma. Now over here, the estimated time for the project, that will be mu, the variance that we need to derive, and for that particular sigma, the formula is B minus A upon 6 all square. Now this is the formula of the variance, so that will be square and it is a total variance. So this is the basic things that we require. Now based on the estimated time, let us calculate first of all the project time duration. So we'll put the time duration which we have estimated now. So for A it will be 4, for B that will be 6 which is estimated, C 13, for D it is 5, E it is 15, F it is 10, for G it will be 6, for H 16, I 10. Now let us calculate the time duration. We'll start our project with a 0 time duration. In a sequence, if we move 0 plus 4, so that will be 4. So we are writing the time duration with under the node. So that will be like 0 plus 4, so that will be 4 weeks. Then after, if we go in sequence, so that will be B, 0 plus 6. So answer is 6. But if you see the node number 3 carefully, this node is having 2 incoming arrow. This node is having 2 incoming arrow. This is known as a merge event. So whenever the merge event is there, there are two or more than two arrows are incoming in the forward path, we need to take the maximum value. Remember my friends, this node number 3 is having two different arrows, so that will be the maximum value you are going to select. So 0 plus 6 is 6, another arrow that is 4 plus 5, and that will be 9. So out of 6 and 9, 9 is maximum, so I'll write down 9 over here. Then after 9 plus 10 is 19. At the same time 0 plus 13 is 13. So 19 is maximum. Now 19 plus 16. So that is 35. If you see the other answers, 9 plus 6, that is 15. 4 plus 15, so there is only one arrow, so that will be 19 over here, and 19 plus 10 is 29. So out of the three options at node number 6, the maximum one is 19 plus 65, that is 35. This is the end of the forward path. Now, similarly, we need to come with the backward path, and backward path will start with this particular time duration, so that will be 35. Now, few of the friends are in a confusion that in a backward path, in which direction we need to move. So my simple answer to those students, like, you need to move in the reverse sequence given in the question. So we'll start with the I first. So if we move in that direction, so that is 35 minus 10, that will be 25. In a forward part, we need to add the value. In a backward path, we need to subtract the value. So then after 35 minus 6,
29.
that is 29. But over here, in a forward, we have taken maximum value where the merge event is there. But in a backward, we need to take the minimum value wherever the burst event is there. Burst events means what? There are two activities are going out. So if two or more activities are going out, that is known as a burst event. So at that point where two or more activities are going out in a backward path, we are going to write the minimum value, not the maximum. Right? So this is the place where students doing a mistake. So 35 minus 6 is 29, but we'll check the other option also. 35 minus 16, so that is 19, and 19 minus 10, so that will be 9. So out of two options, 35 minus 6, 29, and 19 minus 10, 9. So 9 is minimum. So I'll write down 9 over here. Then 25 minus 15,
10.
Again there are two arrows are going out. So I'll write the minimum one. So I'll check other option. 9 minus 5 is 4. So I'll write 4 because it is minimum out of 2. At last, 19 minus 13 is 6. That 9 minus 6 is 3, and 4 minus 4 is 0. So minimum is 0, so I'll write down 0. So this is the end of the calculation part of the time duration. But based on this particular thing, we need to find out the critical path. That is not required in the question. But over here, the last time that you have derived, that is known as a answer of the second question. Second, or identify the critical path, identify the critical activities. So let us find out the, first of all, we have drawn the network. Now we'll go for the answer of the second, that is a critical path. So critical path is a path which consists of critical activities. And critical activities are those activities which does not have a slack time. Now slack time means what? It is a possible delay. It is a possible delay that you have in a project. Simply, if you are delaying any activity and it affects the entire project, that means it is a critical activity. But if you have a slack, then you can delay that slack time duration that you have. So over here, if we see the difference of the time mentioned under the each node, if the difference is 0, that is a part of the critical path. So 0, 0 is of course a 0. If you move in this direction, 4, 4, the difference is 0. So we can go in that direction. So start with A. Then if I come over here, so that is again the difference is 9, 9. So the second activity is D. Then the next is again 19, 19, difference is 0. So next is F. And lastly we have H. Right? So one possible critical path is this. Another possible critical path is also there, that we will write down over here directly from B to G. That is also an equivalent time, so B and G. Another critical possible path, that is B, F and H. B, F, H. and the last possibility, that is C and H. So all are having the difference as a 0, but out of this 4 will have the critical path which is the having a maximum time duration. All 4 cannot be a critical one. So the critical path is the lastly the answer is the one which is having the maximum time duration. So if we have the total from A, so like 4, the next is D, so 4 plus 5, 9, plus 10, that is 19, plus 16, that is 35. So this is the critical path, and this is having a 35 weeks of time duration. So this is the critical path which is having a maximum time duration if you see the answers of compared to all the other one. So the answer to the second is A, D, F, H are the critical activities, and the critical path is having 35 weeks of time duration. Now, if you see the third question over here, so that is what is the expected project completion time and its variance. So this answer 35 is the expected project completion time. So when we say expected, that will become mu over here. So mu is nothing but 35 weeks is the expected time duration to complete this particular project. Right? Now, if you move ahead, they said about finding the variance. Now the formula for the variance is B minus A upon 6 whole square. Remember, you can find out the variance of all the activities like we have found for the estimated time for all activities. So now we'll go for the first one to explain it. What is B? B is nothing but, as I said, it is the pessimistic time. So for A, the pessimistic time is 6 and optimistic time is 2. So 6 minus 2, that is 4, and 4 divided by 6 minus 2, that is 4. 4 divided by 6 all square. Right? So that I am going to write in the last column. You people can find out with the calculator all this variances. So that is nothing but the 4 upon 9 for the first, 0, 9, 1, 4, 4 by 9, 1, 9 and 4. Right? Now, after finding the variance of all, we require the total variance to calculate the Z score to find out the area in the coming time. But the variance, the total variance, it will be of only those activities which are the critical activities, which are there on the critical path. So we are going to find out the total variance of only those activities which are a critical one. So if we see, the critical activities are A, D, F and H. So the total variance, it will be like the summation of the total variance is summation A square, sigma A square plus sigma D square, next sigma F square, and lastly sigma H square. So if you see, the A is having 4 by 9, sigma D is 1, plus F is 4 by 9, and lastly the H is 9. So if you have the total of this, that will be 98 by 9, and it is approximately 3.23. So up to this, if you see, we have calculated out of these 3 parameters, mu, that is the average time, expected time duration for the project, and sigma, that we have derived sigma square now, and sigma square is nothing but this is a sigma square directly that we have derived. So to find out the sigma square, we need to find out the square root of variance. So that square root, the answer of the square root, that will be 3.23. Now let us go for the last question of this particular example. That question is saying that what is the probability? This is the most important part. What is the probability of the completion of the project 1 week before the expected time? I repeat, 1 week before the expected time. So what is the expected time? It is 35. 1 week before the expected time, that is 34 weeks. So they want to find out the probability to complete the project before 34. So let us go for the calculation part now. So I'll remove these particular things. I hope you have written. And the area that we are going to find out, that will be based on the normal distribution bell-shaped curve. So let us draw a normal distribution bell-shaped curve. You all know that the area is 1 and in between the mu will be there. In our case the mu is 35, so that will be equal to 35. They are going to ask the area covered before 1 week, completion of the project time. So 1 week before, so that means 34. So they want to find out this particular shaded area. They want the probability to complete 1 week before the estimated time. So 34 or less than 34. So this shaded area is the answer of that particular question. Now how to find out that one? That the probability that they want is x less than 34. 34 or less than 34. Now for this particular thing we require to calculate a z-score, and z-score is x minus mu upon sigma. X is nothing but a 34 in this particular case, and mu is 35, sigma is 3.23. If we do the calculation of this, that will be minus 0.3 minus 0.31. Why it is showing minus? Because the area is on the left hand side of this particular view. That's why it is minus. Now you remember, people, in statistics we are going to have a normal distribution curve, a bell-shaped curve. So for that reason we are going to have the table of the normal distribution curve, and based on the table we are going to find out the z, that is 0.31. Now if you see over here for 0.31, right? So this is the table. It is a table of a normal distribution bell-shaped curve, and we need to find out the z-score at 0.0. So this is the stage where 0.3 is there. We need to find out at 0.31. So 0.3, and in that it will be 1. So if we see in the 0.3 and 1, that area is over here, that is 0.1217. You can search it in the table. It will be given in all the books of statistics. So the area covered at 0.31 at 0.3 and into the 1. So that area is 0.1217. This is the area. Remember, my friends, only one thing you need to keep it in your mind. The table, this table will give the values. Always that value will be between x and mu. I repeat, that value will be always between the x and mu. So if we see the x in our case, that is 45 and mu is 35. So the area that we have derived, 0.1217 area, that is the area between 34 and 35. So this will be the answer over here. But what we actually required is the area apart from this. So if you see the left hand side area of this particular curve, that is 50%, 0.5, right? Out of the 50%, we have derived this much area, and that is 0.1217. So the answer will not be 0.1217, but that will be 0.5 minus 0.1217, and that will be 0.3783. If we write it in the percentage, that will be 37.83% area. So what is the answer? If you are finding the probability to complete the project 1 week before, so that will be 37.83% chances if you can complete the project 1 week before. So this is the answer of that particular question number 4. Remember, my friends, this looks difficult, but if you remember the sequence and if you do it properly, this is the most interesting project that is developed by US Navy. Thank you so much, and best of luck.